Hey there. So welcome to Solve Linear System using substitution. So this is one of the methods that you're going to use a lot more than the graphing method. It's not used as much as the elimination method, which is coming, but it is pretty helpful. So to warm up, what I want you to do is I want you to just practice solving just really general equations and then just distribute. So for 1 and 2, right here, go ahead and solve the equation. I know I didn't give you a ton of room, so if you need to do it up on the margin or something, that's fine. And then for 3 and 4, just distribute. Okay, so we got to get those negatives down. So hit pause, take a minute to do those, and then we'll jump into substitution. All right, so here are the answers. I didn't show what I was doing to both sides to solve. I just did it. So that is somewhat of a shortcut you can take, but just be careful that you don't miss anything. All right, so the one I really want to focus on is this one right here, number 3. A lot of people tend to forget that you're distributing a negative and a negative to a positive. Everybody usually gets a negative 6x for that one. But then this is the negative 3 times the negative 1. So make sure right here you get a plus 3. Okay. All right. So the reason I had you do that is because guess what? That's all you're going to do in this entire lesson. You're going to solve for a variable, and then you're going to substitute it back in, do the distributive property, and then solve the equation. So if you did great on the warm up, or if you can see your little small error that you made, you're going to do great on the lesson. Okay, cool. So I like to teach this with steps. I like to tell you what the step is, and then we do it. Okay, so the directions say to solve the linear system using substitution. Now, in the future, you can choose between substitution, elimination, or graphing. For this test, however, or the end of this unit, you want to show that you can do all three. So maybe by the end of the unit, you're like, I only ever want to do elimination. Great. After this unit, do whatever you want. But you want to show evidence of all three of those skills in the unit. Okay, so step 1, we are going to solve one of the equations for one of the variables. Solve one of the equations for one of the variables. Both equations have an x and a y. I need to get one of them alone. Okay, so let's talk substitution really fast. If you think about substitution like in sports, you sub players, right? You bring a player off the court, you put a player on the court. You bring a player off the field, you put a player on the field. The idea is that they play equal positions, maybe they have equal skill levels. They're similar, right? You're replacing one with another. The same thing's true for like cooking or baking, right? Let's say the recipe calls for oil and you want to use applesauce instead of oil. I'm pretty sure that that's one you can use. You can make substitutions. Okay, so our goal in this step 1 is to get one of the variables alone so we can see what it equals. Then we can substitute it back into the equation. Okay, so we have a couple of options here. In equation 1, I could get the x alone or the y alone. In equation 2, I could get the x alone or the y alone. Two of those options, there's 4 options. 2 of those options are easier than the other 2. Can you tell what they are? Okay, these are the ones that are easier. This y is easiest in number 1, and this x is easiest in number 2. Why is that? They have a coefficient of 1. So you won't get any fractions if you solve for a variable that has a coefficient of 1. Pretty cool, right? Let's do that. Nobody wants extra fractions, right? So if possible, so that's what I put down here. If possible, choose one that has a coefficient of 1, or if you had to, -1. Okay, I know that's a little bit hard to see, so sorry about that. Okay, so you could either solve for the y in the first equation or the x in the second equation. I'm going to solve for the y in the first one just because it came first. That's the only reason why I'm choosing that. We could just as easily solve for the x in the second one. Okay, so I get -3x plus y equals 2. I want to get y alone, so I have to undo the 3x by adding it to both sides. And let's just put it in order, pretend like it's slope-intercept form. I get y equals 3x plus 2. Okay, I'm done. That's the first step. Well, I'm not done with the whole thing. I'm done with the first step. Okay, now step 2, here's where we do the substitution. We're going to take something out and put something in. So we are going to substitute the expression from step one. The expression is the thing on the other side of the equal sign. So what I just highlighted in purple. Substitute the expression from step one into the other equation. So the other equation also has an x and a y in it, but we don't know how to solve for two variables. So we have to use this method, which actually does solve for two variables. So if we take the y out of the other equation and put in what y equals, then we can figure out what x is, and then we can figure out what y is. Okay, I know that sounds kind of confusing, but hang with me. Okay, we're going to plug it into the other equation and solve for the remaining variable. So here are the steps. We are going to distribute, which is what we did in the warm-up. We are going to combine like terms, which is what we also did in the warm-up. And then we're going to undo. That's how we solve. Okay, so check this out. I'm going to rewrite it just so you can visually see what we're doing. So y equals 3x plus 2. This 3x plus 2 is the expression from equation 1. Okay. Y equals, oh, sorry, it's not y equals. The second equation, just kidding. Because remember, we got to plug it into the other equation. The other equation is x plus 2y equals 11. Okay, so here's what we're going to do. We're going to take this y right here out of this equation. And we're going to plug in what y equals. So right here, this y comes out. This 3x plus 2 goes in. So that's my substitution. High five your teammate. Go off the court, go on the court. So here's what it turns into. I get x plus 2. And instead of the y, I write 3x plus 2 equals 11. Don't forget to complete the equation. So I took this y out and I put this in its place. And it's 2 being multiplied by that, which is why I wrote it as distributive property. Okay, I hope we're doing okay. Hang in there. All right, now I'm going to distribute just like it says to do right here. So I'm going to get x plus 2 times 3x is 6x. 2 times 2 is 4 equals 11. I'm going to combine like terms. So this x is going to go with that 6x, and I get 7x plus 4 equals 11. Now I'm going to undo. So I'm going to subtract 4, and I got to go over here. 7x equals 7. And then divide by 7, x is 1. Okay, it's a pretty good indication that you're on the right track if you're getting integer answers, so positive or negative whole numbers. All right, if that part didn't make sense, hit pause, go back and watch it again, or ask for help. Okay, so guess what? The solution to a system of equations is an ordered pair. We just found the first half of the ordered pair. It's 1 comma something. If we know one of the variables, how do we find the second one? We plug it back in, right? So check this out. Here's where we have a little bit of choice, okay? We're going to take our answer from step 2, so the one we just did, and plug it back into either original, this is important, into either original, oh, well, what did I put there? Why is it not fitting? Oh, either original equation, sorry about that, and solve for the second variable. Should have added a third blank there. Okay, so x is 1. I'm going to go back to my original equations up here, the ones that I highlighted. Okay, let's put a little box around those guys. And I'm going to plug 1 in, so one of those. Pick whichever one you want. I think it's easier to plug 1 in to the second one. Yeah. Okay, so my second equation was x, well, I gotta go look. X plus 2y equals 11. And I know that x is 1. So now I get 1 plus 2y equals 11. Subtract 1 from both sides. Go over here. 2y equals 10. Divide by 2, divide by 2. Y is 5. I just found the second half of the ordered pair. Yeah, sweet. So I'm going to write my solution as an ordered pair. And now here's the key to this. And I'm going to check it in both original equations. Let's make sure it actually works. So my ordered pair would be the x value of 1, the y value of 5. So there's my ordered pair. I'm not going to put a box around it to say that's my answer until I check it though. Okay, that's my preference. I want to get these right if I'm doing all this work. Okay, so 1 comma 5. So -3 times 1 plus 5 should equal 2. Yep, -3 plus 5 equals 2. I checked it in the first equation. Now I get 1 plus 2 times 5 equals 11. I'm checking it in the second equation. 1 plus 10 is 11. Yay! Therefore, 1 comma 5 is the point on the coordinate plane where those two equations cross. Okay, that's a lot. So we're going to do a couple more. Don't worry. And then if you have questions, watch it again or come ask for help. Okay, so let's move on. All right. So number 2, solve using substitution. Remember, we want to look for one that has a coefficient of 1. And the only one that has a coefficient of 1 is that guy right there. So I'm going to get that x alone. All right. So x minus 2y equals -6. I'm going to add 2y to both sides, add 2y. Now, this isn't going to be in slope-intercept form, but it's still nice to put the variable first, just because in distributing it makes it easier. So I get x equals 2y minus 6. Okay, now I'm going to take this. This time we solve for x, not y. It doesn't matter. Now I'm going to take this, and in the other equation, I'm going to put it right there. I'm going to take x out, put what x equals in. Yeah? Okay, so then I get 4 times 2y minus 6 plus 6y equals 4. And maybe it would have been a little bit easier if I'd done this, so I apologize if that was confusing. It might have been easier to say take this and plug it in, because that's actually what I did. Okay, I took that. Okay, now I'm ready to distribute. So 4 times 2y, 8y. 4 times -6 minus 24 plus 6y equals 4. Combine like terms. This 8y is going to add to this 6y because it's a plus 6y. So it gives me 14y minus 24 equals 4. Now I'm ready to solve. So I'm going to add 24 to both sides. And I get 14y equals 28. Ooh, I like what I'm getting because 28 is divisible by 14, which means I'm going to get a whole number. Yay. Okay, and y equals 2. All right, I have half of my ordered pair. Now I'm going to plug it in and find the other half. I think it's easier to plug it into the first one. So I get x minus 2 times 2 equals -6. X minus 4 equals -6. Add 4 to both sides. X equals -2. Okay, I've done all this work. I want to make sure that my ordered pair, -2, 2, is the right answer. So right over here, I'm just going to plug it in. Again, you don't want to do all this work and then it not work out. Okay, so I get -2 minus 2 times 2 equals -6. -2 minus 4 is -6. Okay, so that one works. It checks out in the first one. But remember, it's got to check out in both of them. Okay, 4 times -2 plus 6 times 2. Does that equal 4? Okay, so this gives me -8 plus 12. Sweet, equals a positive 4. Yes, it works in both. Thank goodness, all that work was worth it. Okay, so this, my friends, is the final answer. The point where those two lines intersect is at -2, 2. Okay, cool. How we doing? All right, last examples. We're going to look at this in the context of a small word problem, okay? This is an older problem, so I apologize. It's not super updated for like the way we do internet charge, the way we charge for the internet now, but I think you'll get the idea. So many businesses pay website hosting companies to store and maintain the computer files that make up their website, so all the stuff behind the scenes. Internet service providers also offer website hosting, meaning that they'll put your website up. The cost for website hosting offered by a website hosting, it says hosting, hosting company, and the internet service provider all shown in the table below. Find the number of months after which the total cost for the hosting is the same for both companies. Okay, so I recently wrote a blog, and I could either buy a domain name and post my blog there, or I can write a blog and then just generically get it posted on the website I was using. So if you want to detail it or like make it Indiana Shones at indianashones.com, I could have made it a little bit more clear, but I went for the free option. Okay, so let's look at the situation. We got to first decide if we're writing our equations in slope-intercept form or in standard form. Those are the two most common. Okay. This problem says the internet service provider gives me a setup fee of $10. That's a one-time fee, and it's $21.95 per month. Then the other one has no setup fee, and it's $22.45 a month. So they've basically given me a slope and a y-intercept for both problems or both situations. So I'm going to write my equations in slope-intercept form. So I'm going to call this company 1 and this company 2. For company 1, I'm going to say the total cost y is equal to the $21.95 a month. That's my slope because it happens over and over and over, times x, plus the $10. So y is the total, x is the number of months. Okay. It's okay if you're not to the point where you're like defining variables and stuff, but we'll keep working on that. So my second equation is going to be the total cost is equal to $22.45 a month. And there is no sign-up fee, so the y-intercept is 0. So I don't write plus 0 because that's kind of weird. Okay, so what I like about these is they both equal y. So think about this. If a equals b and b equals c, what does a have to equal? C, right? So guess what? If I do substitution, this right here is going to go in for y right there. Yeah. So I get 2245x equals 2195x plus 10. So remember, we got to get our x's on the same side of the equation, and it's easiest if you move the smaller one. So I'm going to subtract 2195x from the right and 2195x from the left. What does that give me? That's like 50 cents, right? So I get 0.5x equals 10. Then I'm going to divide both sides by 0.5. Anytime you divide by 0.5, it's the same thing as multiplying by 2. Because I'm dividing by half. And in 10, there are 20 halves. Okay, so let's check this though. The question says, find the number of months after which the total cost will be the same. Is x the number of months? It is, because up here we said x is the number of months. We got 20, so then we can say the cost is the same at 20 months. Okay, sorry about that. Someone joined in. 20 months. So eager to come to class. Okay, so this word problem is a little bit interesting because they only wanted us to solve for x. If the question said after how many months are they the same and how much is the cost, we'd have to plug the 20 back in to one of the equations to get the answer. Okay, we're going to do a whole lesson or two on word problems later, so don't feel bad if you're like, ooh, what just happened? Okay, do your best. And I'm just trying to look at the homework here really fast. I'm not sure. I think there's a green and a blue again, so take a look. Remember, blue's always an elevated question, but with the same concept, so to speak. And please get help, okay? This is the second most useful way to solve a system of equations, and you want to make sure you feel good about it. Okay, all right, keep up the good work, and I will figure out how to stop filming because I just changed my screen. Okay, bye.